Hello everyone, welcome to another Dialogues video. In today's video, we're going to be talking about a different topic than what we're used to. It's not fully web development. We're going to be talking about AI. More specifically, what I want you to get out of this video is the knowledge on how to install DeepSeek models or any other open source model securely, safely, and locally on your computer so you can run it for free and you can start doing powerful stuff on your own computer. And at the end, hopefully we can create a very small proof of concept of something that would take a developer maybe a full day worth of work. And we'll see how it can do it in less than 20 seconds. So without further ado, we first need to talk a little bit about DeepSeek. This was in the news everywhere, maybe 2 or 3 weeks ago. DeepSeek is a Chinese AI company that was recently trending because they released an open source LLM model that in some benchmarks was better than OpenAI's, Google, and Anthropic models. Let's talk for a little bit what's a model, what's an LLM model. LLM means large language model. And these models is what powers all these recent development of AI. What a large language model is, without getting too technical, it's just a gazillion of numbers organized in what's called a matrix. A matrix is just a bunch of columns and rows of elements, but for LLMs, inside each one of the cells of the matrix, you have numbers. In the case of an LLM, we're talking about very big matrices, and we're talking a huge amount of matrices, one after the other. So when the LLM runs, it does a bunch of mathematical operations to determine what word comes next after a given input. And the way how it does that is, again, it runs a bunch of math operations over all these matrices. And at the end, it's going to give you what's the expected next word. So maybe you've used ChatGPT before. I hope you have. And what you do is you type something, you type a request, you tell it what you want to do. And what the model does is it grabs the sentence that you wrote, it passes it through the LLM, and the LLM is going to tell you what's the next word that comes out of it. And after the word, it does it again. What's the next word and what's the next word? And that's how it iteratively, it's going to create the whole response for you. So the magic is within those matrices. When we talk about an open source model, so I'll go back real quick. OpenAI is the name of the company that creates models like ChatGPT. They're called GPT O3, O1 mini, GPT-4, etc. All those are made by OpenAI. OpenAI is a closed company, so all of their models are proprietary. Nobody knows what's inside those matrices, that secret formula. Same with Google and their Gemini models, they're closed source. Anthropic with Claude, those are closed source. These are all industry leaders. Meta went through a different route and they created models called OLLAMA, and those are open source. You can download for free, install on your computer, and run them without having to pay somebody for their proprietary models. So what DeepSeek did, just coming back to the beginning of the conversation, is they created a model, and I'm not going to go into the details of how they did it. That might be for another episode, but they created a model that for many different cases outcompetes OpenAI, Google, and Anthropic on results. But the most important thing is they open sourced it. This means you can run these models on a server or in your computer and have even better results than paying $20 to run one of the latest OpenAI models. So a little bit more about DeepSeek and their models. Like I said, it's a Chinese AI company. And the fact that they're Chinese makes it the core of this video is teaching you how to run this locally. Because if you run DeepSeek from their website, like if you go to deepseek.com and click here to start, I'm not going to do it. They're going to take you to their online app, very similar to ChatGPT, where you can ask the model questions and it's going to tell you stuff or tell you the responses. The issue with that is all this data has to go to China, go through their servers, process information. And yes, they give you the result, but at the same time, the Chinese government and the Chinese Communist Party, they're having access, we're giving them access to all your information. I know the same thing happens with OpenAI. When you make a request to ChatGPT, it basically goes through their servers and they save the information. They might use it for training, maybe not OpenAI, but other companies. But the things I personally feel much more secure with my data running through US servers than Chinese servers. If it's even more important if we're talking about sensitive information, proprietary data from companies, from your clients, personal data that can identify you. I really don't want that stuff flowing through Chinese servers and giving that information to the Chinese government. With what we're going to do today is basically grabbing the model that's running on these Chinese servers. Since they open sourced it, they gave away the formula. We can download that formula, install it on our computer, and the requests are never going to leave our server. I could even turn off my internet, ask it questions, and it's going to process everything locally and give me the same response as if it was running on the Chinese servers. The two most important models that DeepSeek created, the first one was called V3. Of course, there are others before that, but the most popular one was V3. And this is comparable to ChatGPT. It's like an assistant that you ask it any type of general question, and it's going to give you a very good answer. The breakthrough was with another model called DeepSeek R1, which is a different type of model called a reasoning model, where when you ask it something, it's going to think or reason or think for a little bit. It's going to figure out some gotchas in the question, in the process. You're going to be able to read the whole thought process of the model. And when it finishes thinking, it's going to tell you the response. And there are some nuances there. Again, might be useful on another episode, but those are the main two differences. The V3 model is like an assistant, and the R1 model is like a deep reasoning model that helps you with highly technical stuff. And it's the one we're going to be testing. So how can we run LLM models locally? The best way right now is using a tool called OLLAMA, not to be confused with Llama, which are the models by Meta, by Facebook. OLLAMA is a program or a software that lets you run LLM models locally on your computer. So the first thing we're going to do is go to OLLAMA.com. Again, this was created by Facebook, by Meta. You download the installer, you go through the steps. It's very simple, just like installing any other program on your computer. And once you have that, then on your terminal, you'll have available the OLLAMA command to do stuff with models. So I'm not going to do that because I already have it installed, but it's as simple as clicking download. It's going to recognize your operating system. I'm using Mac, so it's going to download a Mac installer. If you're using Windows, it would be a Windows installer and so on. After you have OLLAMA installed, at that point, you have the power to download any model that's open source, or if you're super smart, you can create your own model and run it using OLLAMA. The other great thing about OLLAMA is that they also created a directory where companies and individuals can publish their models. And it's a very easy interface to navigate and to download them. So just going to OLLAMA.com, clicking here, models, and it's going to show you the most popular ones, but you can sort by newest. And the one we're interested in is DeepSeek R1. So let's click that one to talk a little bit more in details about memory consumption and resources. So again, remember, you're going to be running this locally on your computer. I have a Mac Studio with 32 gigs of RAM, and the RAM is very important to run models locally or on a server if you want to run this on a server. Because the RAM, when you run a model, it's going to load the entire model. Well, maybe not the entire, don't take this literally, but it's going to load the model in memory, because memory is, for a computer gets much faster access to RAM memory than to your disk. So yes, when you download the model, it's going to be stored on your hard drive. So you're going to need X amount of gigabytes to download the model. But when you run it, the same amount of gigabytes are going to be used on your RAM. So if you have a 16 gigabytes RAM on your computer, you will not be able to run a 64 gigabytes model. And you can think of the size of the models as flavors. They're related to a parameter an attribute called parameter of the model. So DeepSeek R1 is the name of the model, but there's like this extra piece, which is the number of parameters that you're going to use to run the model with. And you can remember, the model is a bunch of matrices, not a bunch, a ton of matrices, one after the other, that the model is going to run operations on mathematically. And the parameters, you can think about like the relation between the matrices. The term is weights, the weights between the parameters of the matrices. The more parameters you have on your model, the more learning you'll get out of the model. So in the example of DeepSeek R1, this number here tells you that there's a flavor of the DeepSeek R1 model that's 1.5 billion parameters. That's the smallest one. And the largest one has 671 billion parameters. How that translates to size is here on the dropdown. If you want to use the 1.5 billion parameters DeepSeek R1, you're going to have to have available 1.1 gigs of space on your hard drive. And you're going to need to have at least 1.1 gigs of RAM available on your computer to run it. So what I would recommend is, to start, you can download the 1.5 billion parameter, because it's the lowest one in terms of resource utilization that you're going to be required to use. And you just choose that one from the drop down, and right next to it is the instruction to run it. And if you don't have it, OLLAMA is automatically going to download it for you. I already have it downloaded, so it's not going to download it, but it is going to run it. So clicking this icon here, I just grab everything, copy, and then paste on a terminal. Again, if I didn't have it downloaded, it's going to download first. You're going to see don't have to do anything. You'll just see that it's pulling or transferring in the model, installing it, and after it's done, it's going to show you this. And here you have the model running. It's asking you to send a message. So you can say, hi, what's the capital of the US? And we'll talk about this thing in a second, but the answer is the capital of the United States is Washington, D.C. So we have effectively DeepSeek R1 with 1.5 billion parameters running in my computer. This is great for small things, but if you ask it a very complex question, it's going to have issues giving you the right answer, which is what I want to get to at the end, like asking it a very complex question that a programmer would need several hours to do, how this can do very quickly. So we already have the 1.5 billion parameter. If depending on how many resources you have in your computer, remember I have 32 gigs of RAM on my computer. So I'm able to run up to this 32 billion parameter DeepSeek R1 because I would need 20 gigs of RAM free on my computer to load it in memory so it can run. I also have this model downloaded on my computer, the 32 billion parameter, but the process is the same. You copy the instruction here and copy, and on your terminal, you paste it, and boom, you can ask the same question. See if it thinks a little bit different. Now, since it's a bigger model, you'll notice that it takes a while longer. And notice the response is much slower too, because the tokens per second that it's using to run on my computer, it's just using so many more resources, and it's harder for my computer to give the outputs. If you notice, it takes a while for every word to be printed. It's not like it gives you all the output at once. And that goes back to what I was explaining about the way how the LLM works. It's just a bunch of matrices. And what the model does at any time is, let's imagine it's here. It's going to grab my question, hi, what's the capital of the US? Right after it, it's going to append or paste everything that it's outputted up until that point, which let's imagine it's here. So it's going to put all this information until federal back into the model, run it again, and the model is going to output, okay, now the next word is district with a space because this is a token. And so in the next iteration, it's going to grab everything plus the word district, running again through the model, and the answer is going to be the next word or the next token is and. It hasn't finished yet. So again, it goes through the following iteration. It grabs everything so far, runs it again through the model, all those 20 gigs of matrices, and the next token is not, and so on and so on. That's why when you run a larger model, it takes longer because each operation, it just has to do so many math operations to give you the next result. But at the same time, since the model is larger and it has more parameters, you get a higher quality response because you're basically allowing it to think better. I know think it's a loaded word here because models don't really think, they're not human. But like if you start reading what it's thinking, right, for this simple question, hi, what's the capital of the US? It starts thinking, okay, so I need to figure out blah, blah, blah. I remember from school, it didn't go to school, but it was trained with material that had this information. Maybe somebody was saying when I went to school, the capital is in New York. And then it has things like, wait, but isn't there a state called Washington too? See, so it recognized there's a state called Washington, maybe there's a gotcha there. If it was too fast and it wouldn't have thought about this, maybe the answer would have been different. But this reasoning aspect of the model is what makes it, it gives you a little bit of that uncanny valley situation where it's not thinking, but it makes you feel like it's thinking. Anyways, at the end, the answer it gives is the capital of the United States is Washington, D.C., and a little bit more information. All right. So yeah, that's the video for today. We're going to do a couple more things, but you are effectively, if I shut down my Wi-Fi and I ask it this question, it's going to answer me correctly because it's not making any requests out of my computer through the internet, through any server. It's running everything locally from memory on the model that I downloaded. Okay, so the last thing I want to do is give it a very complex problem and see the difference between the 1.5 billion parameter and the 32 billion parameter. And you can do the same, maybe compare it with on the internet, on social media. You'll see similar tests of asking it complex question on OpenAI, or like ChatGPT, DeepSeek R1, Anthropic, Claude, or Google Gemini, and see what the responses are. These reasoning models, just to reiterate this, are very good with, like the asking what's the capital. We didn't really need all these heavy thinking. We needed something quick. The capital is Washington. But when you run the reasoning models with a lot of parameters, it's going to think for a while. So these models are better suited for engineering questions, science, something that requires deep thinking to get to an answer. Okay, so without further ado, the complex problem, quote unquote, that I want to give it is, let's run the 1.5 billion parameter. And I'm telling it that I'm prompting the model by started saying that it's an expert web developer, and I need a single HTML file that when it's loaded on a browser, it shows a rotating square with a yellow circle inside, bouncing within the walls of the rotating square. So I want something that I can run on my browser that shows a rotating square with a yellow ball inside, bouncing within the walls of that rotating square. So there's many ways to do this as a web developer, but there's also at the same time many things that you have to consider: collision with the walls, rotating the square, making sure that it's, when it bounces through a wall, it bounces to a logical place and not randomly all over. If I had to do this without AI like 5 years ago, it would take me a good couple hours to do. So we're asking it this question to the 1.5 billion parameter. I don't expect something that works out of this response, but let's see. Remember, the reasoning model, the DeepSeek R1 reasoning model, it thinks for a while, and everything that it thought, it's going to be shown within these think tags. You can read all the think on your computer, and then after the closing think tag is the actual answer of the model. So it told me, here's the complete HTML file. I'm going to grab that. I'm going to copy, go to my trusted cursor, save it as, let's do yellow.html. Let's do yellow 1.5 because it's a 1.5 billion parameter. Okay. Now let's ask the exact same question to the 32 billion parameter. The exact same question. Now this is going to take longer because it's thinking, like I said, it's going to think. It's a larger model. The tokens per second are way smaller because it's a bigger model, and the resource utilization, it's much larger. So while it thinks and it gives me the answer, let's open this file on the browser. Let's open it here. It's yellow 1.5. Yep. It's just a gray square with nothing in it. Yeah. Not even errors in the console. And the source code. Yeah, it has a title, style, body, a script, but it it looks like it's logical. There might be some errors in here. I'm not going to debug it. But the bottom line is it doesn't work. Now, this thing is still thinking the 32 billion parameter. It's thinking, yeah, all these thoughts, again, this is not a human. It's not really thinking. But if you read the reasoning, it's very weird. It's weird to read this. Wait, no. If I rotate the entire container, both the square, blah, blah, blah. Maybe it's simpler not to use CSS transforms. So it started to use CSS transforms in its thought process, and then it realized that it might not be the best idea. Again, another wait, but rotating the container with CSS, it's easier for visual effect. Now for the circle, so it's going step by step. Another wait, perhaps a better approach. Alternatively, it's still thinking. So a bunch of gotchas. I imagine it's going like a tree, right? Like an algorithm, search algorithm through a tree. It's going deep into a branch, then realizes it's maybe messing up or it's too complicated. It backtracks without eliminating everything that it had thought. Maybe it created some kind of structure with the rectangle doing CSS transitions, and it's working now on the yellow ball. It went through an approach with the yellow ball and it realized it's complicated. So it backtracks only the yellow ball aspect of it. It's not backtracking to the beginning because it maybe thinks that the approach it used for the rotating square is the right one. It just needs to iterate over the yellow ball. Okay, it finished thinking. The output looks the same as the 1.5, just the answer. Here's like what I ask it. Here's an HTML file that creates a rotating square with a yellow circle bouncing around inside it. It's gonna be sad if this doesn't work either. At Dialogues, we had a launch and learn where I shared this with the rest of the team, and we did the exact same exercise live. The 1.5 billion parameter failed, but the output of the 32 billion parameter was correct. It was impressive. And it's the fact that I asked it this same question a week ago doesn't mean that the answer is going to be the same. As a matter of fact, I doubt, well, no, it could be the same answer, but the probability is just so incredibly low because the problem is really complex. If we're talking about the capital of the US, of course, the answer is going to be the same. It's deterministic. There's one answer to the question. But in this case, there's so many different approaches the model could come up with to solve the problem that I really don't think it can get the same answer. Okay, so I'm copying the answer of 32 billion parameter, pasting it on cursor. Let's call it yellow 32b.html. And let's open it here too. 32b. See, it's crazy. It's not perfect. I don't know where it came up with red and blue or cyan colors and the gradient. Obviously the bounces are not natural because I see I didn't tell it that there's gravity. I was expecting the ball to bounce following the laws of physics that we know, that gravity pulls objects down. So it doesn't really know that the ball has to bounce down. I bet if I add that constraint of gravity pulling the yellow ball down on the prompt is going to give me the result I'm looking for. So this is crazy. And this is not the same result we got from the Launch and Learn. It's a different result, very different, but it's what I asked it for. By the time it gives me the answer, I realize that it gave me what I asked for, but what I asked for wasn't clear. So, closing thoughts here in the video. I'm very hopeful about the future now because I think when AGI happens, and I think it's going to happen, it's going to be open source. That gives me hope because it was going to be very dangerous if only one company had closed and private access to a super intelligence. But this is proof that any new development in the world of AI is going to be very likely open source. So the future is looking bright. And also it's a testament to the fact that this is happening. Like there's no denying it. You can't hide from the advances of AI. The ramifications are and are still going to be in the future enormous. So you have to learn how to use it, right? Having a model running locally, this might not be the best idea, right? R1, but it's good to know how to use these tools because the models are only going to keep improving. The companies are going to keep optimizing it, maybe not making bigger models. What I think is going to happen is now companies are going to start focusing on making them more efficient. So we don't need 20 gigs of RAM to run 32 billion parameter. Maybe they optimize the resource, the way how the resources are used, and you can run these large models in like half gig of RAM. When you get to that point, then you can run models basically on every piece of modern hardware, right? Your phone, like a kid's toy, a screen, anywhere that you could have some RAM and a little bit of compute power, you're going to be able to run very powerful LLM models. So don't hide from it, embrace it. The future's looking bright because the competing against the open source community is something very difficult, even with the amount of money and resources that companies like Google, OpenAI, and Meta have. I'm very optimistic about all this, and I hope I can continue creating videos similar to this and even going deeper into more implementations of AI in the real world, in web development. So to stay tuned for those videos, you can subscribe to our channel, follow us in our social media accounts as well. And if you want to learn more, also you can go to dialogues.com, where we're probably going to post an article that goes along with this video and many other AI related articles. So thank you for watching up until now and see you in the next one. Goodbye.